Welcome to True Projects. In this video, we will explain about the project, which is two-stage job title identification system for online job advertisements. Introduction of the project. The project acknowledges the widespread digitization of the process driven by the internet and the social media, leading to a wealth of data across various industries. It emphasizes the need for efficient data processing and analysis to extract valuable insights for informed decision making in a rapidly evolving digital landscape. Data science techniques are highlighted as powerful tools for extracting information from diverse datasets, making sense of various data types, and streamlining traditional tasks. The project recognizes the migration of the job market from traditional channels to online platforms and job portals, creating an opportunity to understand market needs from the wealth of daily shared data. The project aims to benefit various stakeholders, including labor market analysts, policymakers, job seekers, students, and recruiters, by offering valuable insights and guidance. Coming to the problem statement, the project addresses the challenge of classifying online job advertisements characterized by the unstructured text, diverse lexicons, and irrelevant details, making traditional classification methods inefficient. Current approaches struggle to accurately identify job titles, particularly when job ads provide limited information or contain extraneous content. Many methods rely on large, human labeled datasets, making them resource intensive and challenging to update with new job categories. Prior research often focused on English language job ads and specific occupational classifiers, posing difficulties for replication in other languages and settings. To overcome these challenges, the project emphasizes the necessity of advanced text and document representation techniques along with improved feature extraction methods. Abstract of the project. The project offers an overview of its primary objectives and methodologies for tackling the normalization of online job advertisements. The project introduces a two-stage title identification methods that first classifies job ads by sector and then matches them with the corresponding occupations, addresses the challenge of small datasets, utilizing bidirectional encoder representation from transformers, which is BERT. Various text classifiers, including support vector machine, naive Bayes, logistic regression, and BERT, are employed for job ad classification. The experimental results demonstrate that the approach significantly enhances job title identification accuracy with the improvements up to 85% in some sectors. Document embedding based strategies such as weighting and noise removal make the methodology highly effective. The conventional methods for job title identification predominantly utilizes multi-label classification techniques, often necessitating extensive access to labeled datasets. Additionally, many of these approaches are specifically customized for the databases, such as US-oriented Occupational Information Network. Disadvantages of the existing system are the existing system often rely on the extensive label datasets, which can be challenging and resource intensive to create and maintain. This dependency limits their applicability to situations where such datasets are unavailable or costly to obtain. Many of the systems are tailored to work with specific databases like Occupational Information Network, which are primarily designed for the US job market. This restricts their utility in the international or industry specific context. Existing system may not perform well when applied to the smaller datasets or in linguistic contexts other than those for which they were originally designed. This lack of generalizability hinders their versatility. Traditional methods used in the existing system can be rigid and challenging to update. When new job titles or sectors emerge, significant modifications to the training process and datasets may be required, making them less adaptable to changing job markets. To address the challenges faced by the existing system, the proposed system introduces a two-step job title identification methodology. It initially employs BERT to categorize job ads into sectors. In the second step, it utilizes unsupervised machine learning algorithms and similarity measures to determine the most fitting job title within the predicted sector. Advantages of the proposed system are the proposed system reduces the reliance on large label datasets, making it more adaptable and cost effective, especially in scenarios where comprehensive label data is scarce or expensive to obtain. Unlike many existing systems tailored to specific databases or regions, the proposed system is designed to be more versatile and applicable across various job markets and linguistic contexts. The two-stage methodology incorporating BERT and unsupervised machine learning has demonstrated significant improvements in job title identification accuracy, especially within specific sectors. The proposed system flexibility and document embedding strategies such as weighting and noise removal allows for easier adaptation to evolving job markets and the incorporation of new job titles or sectors, reducing the system's rigidity. Literature survey is also known as literature review. It is a critical and comprehensive analysis of existing published research related to a specific topic, field, or research question. The purpose of a literature survey is to provide a well organized summary and synthesis of existing knowledge, identifying gaps in the current research, and offering insights into the state of the art in a particular area of study. Here, we have the literature surveys that we have conducted, providing a solid foundation for this project. But a powerful deep learning model is an integral part of the project strategy to overcome the limitations of literature surveys. By employing BERT, the project enhances the understanding of job advertisements by capturing contextual nuances in the text. This approach not only contributes to the better job market insights, but also highlights the project's focus on leveraging state of the art techniques to address the challenges of traditional literature surveys. So here we have the system architecture of the project. Initially, we load the dataset. After loading the dataset, we do the text pre-processing, which involves removing stop words and cleaning the dataset. After doing text pre-processing, we need to convert the text into vector format. For that, we are using TF-IDF. After converting the data into vector format, we will apply the models and then predict the job category. Here we have the data flow diagram. We execute the project in the following steps, and we will explain detailedly all the steps in the flow of work. So first we import the libraries and then we do the exploratory data analysis. After that, we do the visualization of the data. Then we do the text pre-processing because we are using text data. Here we remove the stop words and convert data into TF-IDF vector. And then we split the data into training set and a testing set. We use the training set for training the models, which are support vector machine, logistic regression, BERT, naive Bayes, CNN 2D. After building all these models, we evaluate it using testing set. And then we do the user testing using user interface. To implement this project, we need software requirements and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to the flow of work, here we have designed various steps to execute the project. The first step is importing the packages. The necessary Python libraries including NumPy, Pandas, Seaborn and Matplotlib, NLTK, TensorFlow and Scikit-learn are imported to provide required functionality for data processing, visualization, machine learning and web development. The next step is exploring the dataset. The jobs dataset is loaded and examined to understand its structure, content and any initial data insights. This step involves data analysis and data quality assessment. The next step is text processing. The text data within the dataset is pre-processed. This typically includes tasks like text cleaning, which is removing special characters or stop words, etc., tokenization, and perhaps stemming or lemmatization to prepare the text for analysis. The next step is visualization using Seaborn and Matplotlib. Data visualization libraries such as Seaborn and Matplotlib are used to create visual representations of the data, which can include various types of charts and graphs to better understand the dataset. The next step is converting text to TF-IDF. The text data is converted into numerical features using term frequency inverse document frequency, which is TF-IDF technique. This transformation assigns weights to the words based on their importance in the context of the document and the entire corpus. The next step is splitting the data set into training set and a testing set. Here we split the data into training set and a testing set, where we use training set for training the model and testing set for evaluating. The next step is building the model. Here, machine learning models are constructed and we have used SVM, logistic regression, naive Bayes, and etc. The next step is training the model. The model is trained using the preprocessed dataset. This involves feeding model with the input features, which is TF-ID of text data and the corresponding target labels if it is a supervised learning task. The next step is Flask framework with SQLite for sign up and sign in. Flask, a web development framework, is employed to create a web application. It includes user sign up and sign in functionality with user data stored in SQL database. The next step is user gives input. Here, user inputs the data. The next step is the given input is pre-processed. The uploaded data will be pre-processed, which means the stop words will be removed and NLTK will be applied. The next step will be the trained model is used for predicting the result. The trained machine learning model is employed to make predictions based on the user input. The next step is final outcome is displayed through frontend. The results or the predictions, the model will be displayed to the user interface. Here we are displaying sample dataset that we have used in the project. It comprises job listings from various industries encompassing a wide range of job titles, descriptions, and requirements. It includes job postings for positions at different experience levels from junior roles to those with several years of experience, spanning diverse job responsibilities and qualifications. The dataset offers a comprehensive view of job opportunities across different sectors, providing insights into the skills and roles that employers are seeking regardless to the specific industry. In this project, we categorize the job sectors. Algorithms which are used in this project are support vector machine, naive Bayes, logistic regression, BERT. As an extension, we also applied hybrid model to produce a more robust and accurate result. Now we will get to know detailedly about all these algorithms. Coming to support vector machine. It is a supervised machine learning algorithm used for classification and regression tasks. It aims to find the optimal hyperplane in a high dimensional space that best separates data points into different classes. This hyperplane is positioned to maximize the margin between the classes and support vectors, which means data points closest to the hyperplane, and they are crucial in determining the decision boundary. It is employed in this project for classifying job advertisements into specific sectors. It is well suited for the task due to its ability to handle high dimensional data and effectively separate text based information into different categories. The next algorithm is naive Bayes. It is a probabilistic machine learning algorithm based on Bayes' theorem. It assumes that features are conditionally independent given the class label. Despite of this naive assumption, naive Bayes is widely used for text classification tasks. It is used for job advertisement classification in the project because of its simplicity, efficiency in processing text data, and its effectiveness in text classification tasks. Coming to logistic regression. Logistic regression is a statistical model used for binary classification tasks. It estimates the probability of a data point belonging to a particular class label, which means class based on input features. Logistic regression employs the logistic function to map input data to a probability between 0 and 1. Logistic regression is applied for job advertisement classification in the project, where the task is to determine if a job belongs to a specific sector. It's particularly well suited for binary classification problems. Coming to BERT, which is bidirectional encoder representations from the transformer. It is the state of the art natural language processing model based on transformer architecture. It's pre-trained on large text corpora and that can capture context and semantics effectively. BERT is bidirectional, meaning that it can understand the context of words by looking at words that come before and after them. It is used in the project to improve text understanding and feature extraction. Its deep contextual embedding can make highly effective for classifying and normalizing job advertisements, as it can capture complex relationships in the textual data. Coming to the CNN2D, it is the extension algorithm that we have used in the project. CNN2D is a type of convolutional neural network typically used for image and 2D data processing. It consists of convolutional layers that apply filters to the input data to learn hierarchical features. These networks are known for their ability to recognize patterns in images and that have been adapted for the other types of 2D data. So here we have represented the performance of algorithms in the tabular format. Here we can see all the algorithm names and the evaluation metrics for each algorithm. Here we can see accuracy for each algorithm, precision, recall, and F1 score. So here we have comparison graphs through which we have evaluated our models. So here we have accuracy score comparison graph where x-axis represents accuracy score of each algorithm and y-axis represents algorithm names. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. And here we have precision score. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here we have recall score graph where x-axis represents recall score of each algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. And here we have F1 score comparison graph where x-axis represents F1 score of each algorithm and y-axis represents algorithm names. The F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making suitable for imbalanced datasets. For execution of the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And here we have the model file, which contain the algorithm information, and this will be loaded into project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. Here we have the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command is used to change the current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command which is python space app.py and click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which will be the local host and the port. So here we have the local host and the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. Here we will paste the link and then click on enter. Here we can see that web page of the project is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a sign up link. First we need to click on it. And here we need to enter all the registration details if we are registering newly. I have already registered and I have an account in it. So we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password to log in. So I'm giving my username and the password. And now we need to click on login. We have logged in successfully. Here we can see a text box where we have to give the job description. Based on that, the system will predict which type of job category the job description is. So here we have the sum of test cases, which means job descriptions. So I'm copying the first job description and we'll give this as the input. So I've copied it and here we will paste it. And now we need to click on predict. So here it is predicted that the job title is classified as cloud architect. Now we will give another job description. This time we'll copy the second job description and we will paste here. Now we will click on predict. So it is predicted that the job title is classified as artificial intelligence. Now we will give one more text. So here I entered other text. Now we will click on predict. So it is predicted that the job title is classified as big data engineer. Now we will give one more text. So here I have entered other job description and now we need to click on predict. So it is classified that the job title belongs to business intelligence analyst. In this way, if we give the job titles and the job description, the system will predict it belongs to which type of category. Now we will sign out. The project successfully addresses the critical need for efficient job and classification and occupation identification in the era of digitization and online job portals. By utilizing combination of machine learning algorithms including traditional SVM, naive Bayes, and advanced techniques like BERT, the methodology achieves high accuracy in categorizing job ads into their respective sectors. Through self-supervised and unsupervised machine learning methods, the project minimizes the reliance on human-labeled datasets, offering a scalable and versatile solution for occupation recognition. The methodology effectiveness is demonstrated by achieving an high accuracy in identifying job titles with even higher accuracy in specific sectors, improving data-driven decision-making and career guidance. This project provides valuable insights into emerging job market trends, specifying highlighting sectors with increasing demand for particular skills such as information technology and telemarketing, benefiting labor market analysts, policymakers, educational institutions, job seekers, and students in adapting to evolving employment landscapes. The project's future scope involves augmenting job enrichment with skills related terms derived from occupation descriptions, aiming to enhance the accuracy of the methodology. Further enhancements can be achieved by investigating alternative machine learning algorithms and similarity measures for more effective job title matching within predicted sectors. The methodology can be adapted to analyze job markets in diverse countries, tailoring the sector prediction step and integrating specific databases for each market. The proposed methodology's applicability can be extended to other domains beyond job market analysis, including the classification and matching of titles in various text-based datasets. These are the sources that we have consulted and cited in this project. These sources provide evidence, support, and context for the claims, arguments, or findings presented in the document. Proper referencing is essential for academic integrity, credibility, and giving credit to the original authors or creators of the work.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.